Alright, here we're ready for a few more examples. Here's the quick check after that last example. What I'd like you to do is pause this video right now and see if you can set it up and solve it, and then we'll look at the answer. So go ahead and pause it, see if you can set up the equation and solve it. If not, you can watch the video, but it'd be best to try it on your own first. So pause this for a minute and then watch me do it. See if you get the same thing. Alright, hopefully you tried it. Let's set it up now. Here's my legs over here that make up the right angle. So I know they're going on this side together. And the hypotenuse over here will be on the side by itself. So let's see, I got this leg to the second power. Alright, I took the x first, I'm sorry. And then this leg to the second power equals the hypotenuse over here to the second power. Remember, we're going to put that in parentheses and put the power on the outside. Your calculator will do it good like that. So if you put that into the calculator, of course, 6 squared, 6 times 6 is 36. The other part should come out to 72 if you've done it right. Then what do we do here? Alright, so we're not solving for the hypotenuse, we're solving for one of these legs. So I can see we need to get rid of this addition with subtraction, so we'll subtract 36 from both sides. That leaves us with x squared over here, and 72 minus 36 is 36. Now we're ready, got the square all by itself, we're ready to take the square root of both sides. Here we cancel out the square, we get x equals the square root of 36, which is exactly 6. Alright, so hopefully you tried that by yourself and saw that you got that correct. Our example 4, I don't see a right triangle. So we're solving for this side over here. I know, well, if I go straight down and make the right angle here with a segment, you can draw that in on your paper, and that is actually 90 degrees right there. So we have the right triangle here. So we need to know these legs here. Well, I can see that this is the same as this side over here. That's going to be 8 on this leg. Now this leg down here, I can see this whole side here is 11. But this little piece right here is the same as this top. This is 5. So if I take the whole side and subtract this piece right here, take it away, I'm going to be left with this piece, which is 11 minus 5, or 6. So this leg is 6. So now we have our two legs of this right triangle. We can set up Pythagorean's theorem to solve for this hypotenuse they're trying to find in this picture. So I got a leg squared, 8 squared, this one. This other leg to the second power equals the hypotenuse to the second power. Don't forget the powers on all of them. Put that into your calculator. 8 squared plus 6 squared equals 100. Now we're ready to take the square root of both sides. And we get x equals the square root of 100, which is exactly 10. So there's a good one where it's not just a right triangle. We had to draw it in here, go straight down, draw on the right triangle, figure out, and take a look and see if we can figure out the legs so we can figure out this hypotenuse. Here's this quick check. Again, to get the maximum benefit from this lesson, you should try this on your own. Okay, see if you can figure out what it is. So pause this video maybe for a minute, see how far you can get, and then check your answer. Alright, hopefully you paused it and take a look. It's better than just copying this. Try and think for a little bit on this. So I can see we've got our right triangle up here. We should really draw on this right angle here. I'll go ahead and do that. So there is a 90-degree angle here. So here's our right triangle. We're looking for this leg right here, right now, x here. What do we know? We know the hypotenuse is 25, but don't know what this leg is yet. So let's see. We know this whole side is 34, and this little piece is the same as over here, 10. So if this is 10, I'm going to take this whole thing and take away this part right here. I'll be left with this piece I want to know, this leg here. So 34 minus 10 is 24. So now I know this leg is x, this one's 24, the hypotenuse is 25. We're ready to set up that equation. That says this leg squared plus this leg squared equals the hypotenuse squared. So we'll go ahead and square both of these things with our calculators and get numbers. So 24 squared is 576, 25 squared is 625. So now we'll isolate the x term, get rid of this plus 576 with minus. So we end up with x squared equals 49 over here. Now we're ready to take our square root of both sides. And we get x equals 7. The square root of 49 is 7 exactly. A few more examples to look at. Here's a nice word problem. A pool table measures 4 feet by 8 feet. What is the distance to the nearest tenth of a foot from one corner pocket to the opposite corner pocket? So from this corner to this corner, the diagonal basically of this rectangle. So we can see we got a right triangle here, and the legs are 8 and 4, so we're trying to solve for this diagonal right here. We'll call it x for right now, or the hypotenuse of this right triangle. So we set it up, leg squared plus leg squared equals hypotenuse squared. These are the legs again. It's the hypotenuse. Put that into our calculator. What do we get? 80. Now we're ready for the square root. So x equals approximately, rounded to the nearest tenth, 8.9. You should be trying that, all those steps with your calculator. Make sure you're getting the same things. Got a little quick check here. It says find the length of the diagonal of a rectangle with, I'm sorry, find the length of the diagonal of a rectangle with a length of 12 and width of 5. So I've drawn it. It told you to draw this picture, so you should do that in your notes. When I drew a rectangle, okay, this side is 12, this side is 5. We're trying to find the length of this diagonal right here. So again, we got a right triangle here with our one leg is 12, one leg is 5, and the hypotenuse is what we're looking for. Set up the equation. It should look like this. Is our leg squared plus our other leg squared equals our hypotenuse squared. Throw that into the calculator. You should get 169. We're ready for the square root. So again, this just cancels out the power and leaves us x, and the square root of 169 is 13 exactly. I'm going fast, but you can pause anytime you need to. Just trying to get through all these examples with this second video. Example 6, the older square-shaped floppy disk had a perimeter of 21 inches. What is the diagonal length of the diskette to the nearest tenth of an inch? So this has a few more steps to it. So I drew our old floppy disk, square-shaped. All these sides are the same. And, you know, I've got these measurements on here. Where do they come from? Well, they came from this. The perimeter is 21 inches. So we know the perimeter is adding up all these sides. In a square, they're all the same. So there's 4 sides. So we take the perimeter equals 4 times how big a side is. Now, we didn't know what that was yet. I should have covered these up first. So now I substitute in the perimeter is 21 inches, and it equals 4 times how big one side is, or 4 times the side. So we divide that by 4, and we get this answer I had on here. Each of these sides are 5.25. Now to find this diagonal, we've got our right triangle right here, and we know each of these sides, these two legs, are 5.25. So we're ready to set up Pythagorean's theorem with that. So it looks like this. The one leg squared plus the other leg squared equals the hypotenuse squared. We throw this side into our calculator. You should get 55.125. Now we take the square root, and we get x equals approximately 7.4 inches across that diagonal. Okay. How many we got left here? Here's another example. This one with a bunch of shapes in here. we can see we've got some right triangles. I forgot to cover up some stuff here. What did I do? Let me take a look at the original notes. Nah, I guess that was all in your picture. Okay. So they want to find the length of this whole side over here. Okay. Whoops. Messed up here a little bit. All right. So I know it's all these pieces. This piece plus this piece plus this piece will equal this whole side here. So I know this piece is the same as over here, 10. So I got to figure out these, and that's where our Pythagorean theorem comes in. These are right triangles. These are actually the same size right triangles. So if I figure out this piece, I know what this one is. So let's take a look here. I'm going to call this side y, not x, like the whole thing here. So I'm going to solve for this piece y here using Pythagorean's theorem. That is one of the legs. The other leg is 8, and the hypotenuse here is 10. So we'll set that up and solve for this little piece right here, y. And again, this one will be the same. Then we can add these three pieces up and get the whole length of x here, this whole distance. So setting up this right triangle with Pythagorean's theorem, we should get this leg squared, y squared, plus this one, 8 squared, equals the hypotenuse squared. So we'll square both of these numbers, and it looks like this. 8 squared is 64, 10 squared is 100. Now we'll isolate the y squared term here by getting rid of this plus 64 with minus 64. We end up with y squared equals 36. Now we're ready to take the square root. And the square root of 36 here is 6. So this little piece here is 6. And this one's the same. There's the same right triangle over here. This one is also 6. So now we see we got 6 plus 10 plus 6 to get this whole distance x. I went ahead and wrote it like this. X equals that little y piece plus that 10 in the middle plus that other y piece on the end here. Or 6 plus 10 plus 6, which equals 22. This whole distance is 22. What else we got left here? This example 8, save the quick check for you to do a little later. So example 8, it says find the distance between these 2 points using Pythagorean's theorem. So 3, 2, I graphed it right here, 3, negative 2, I'm sorry. So I went 1, 2, 3 spaces to the right, because it's positive 3, and then down 2 for the y coordinate, and there's that point. And then this other point, negative 1, 1, you can graph it. Negative 1 means go left 1, and then the y coordinate is positive 1, so you go up 1. So we're trying to find this distance here. So what I've done is drawn a right triangle here from one point to the other. And now we can see solving for this distance is the hypotenuse in this right triangle. And I counted the spaces here, 1, 2, 3. The length of this side is 3. The length of this side of the right triangle is 1, 2, 3, 4. And you could have done the same thing drawing it on top. You'd get the same distances for these legs. So here we got the 2 legs. We're solving the distance as this hypotenuse. We're going to call it x right now. So we set up the Pythagorean's theorem that way. The leg squared plus this other leg squared equals the hypotenuse, that distance we're looking for, squared. Throw that into your calculator. You should get 25. Take the square root, and you get x equals 5. That distance between those 2 points using Pythagorean's theorem is 5. So that's all the examples. You should have the practice pages coming up next. Go ahead and work on those and turn those in. Very good. Let me know if you got any questions.